What is a Mosfet? It's a switch that's activated by voltage. What's it used for on the iPad? When an iPad is using the battery, the voltage and therefore current is being supplied by the battery. What happens if the power cable is connected? The iPad must stop being powered by the battery, and now the battery must receive charge instead of outputting power. Of course, the process is much more complex than this. When the cable of an iPad is connected, the voltage manager sends a voltage charge to the Mosfet. Now, with that signal, the switch or Mosfet closes and passes current from the power cable to the battery. If the cable is disconnected, the voltage manager stops sending the voltage charge or signal to the Mosfet. There is 0 volt at the gate. So the switch or Mosfet opens and no longer passes current to the battery. Now the battery starts outputting its voltage again to power the iPad. So if the Mosfet is damaged, the device does not charge or turn on because the voltage from the power cable does not reach the battery. We have an iPad 6 A1893 that won't charge and won't turn on. Is it a problem with the charging chip, as is a common occurrence? How do we rule out the Mosfet? Simple. It's common that if the Mosfet is damaged, we don't have a gate voltage reading, or gate. In the case of this iPad, we have 0 volts. With the battery disconnected and with the power cable connected, we can observe that the gate has 0 volts, which is not normal. The VDD main has 3.74 volts, which is normal, and the VBAT has 0 volts, which again is not normal. If we connect the battery, obviously in the VBAT we will have the battery voltage 3.2 volts because the battery sends its voltage to the whole VBAT line. So we can measure with the battery disconnected. If the Mosfet is good, there should be a VDD main and 3.7 volts at the Mosfet gate. Normally a device with a damaged charge chip and a good Mosfet will measure at VBAT about 0.6 volt, but with the VDD main voltage at the Mosfet gate. In this case, we have a defective Mosfet with no gate voltage, so we'll replace it. We have to look for a P-channel Mosfet from another device. We remove it with heat with the quick 861DW soldering station at 380 degrees Celsius and a speed of 26, and then put it in. It's somewhat tricky to place a Mosfet, so we have to look at it in 3 dimensions to see if it's been well soldered. Now we measure. We have in the output of the battery VBAT a voltage that starts with 1.6 volts and falls to 0.6 volts and oscillates between 0.6 to even 1.9 volts. We have in the door of the Mosfet 3.74 volts, and we have in the VDD main line the same 3.74 volts. This already indicates that the device is fine. We can connect the battery and connect the cable again and measure 1.7 amps, which is a perfectly normal charge for an iPad. We put it back together to check its operation and it works perfectly. In this way, we are repairing an iPad by measuring with voltages. You can purchase the multimeter and the heat station we recommend from the links in the description of this video, and for all kinds of parts and tools, visit forphones.eu. Thank you very much for watching our video. See you next time. This was 4 Phones, more than spare parts.